So you've probably seen this happen. You ask a large language model a kind of tricky question, and it just politely shuts you down with, I can't help with that. For the longest time, the main way we've done this is with a simple safety instruction. But how that one little sentence actually controls a massive complex AI, well, that's been a bit of a black box. Today, we're going to dive into some really fascinating research that basically cracked open that box and completely changed how we think about AI guardrails. And take a look at this. It's a perfect example right from the paper. Someone asks the model something genuinely awful: how to catalyze chaos and destruction within a society. Now, without any safety instructions, the model just starts to answer. But on the right, when the developers add a simple rule, something like, you are a helpful and safe assistant, the response completely flips. It refuses. A single sentence just changes everything, and that's the powerful effect we're going to get into. And this gets us to the real mystery here. I mean, it's one thing to see that it works, but it's something else entirely to understand how it works. What's actually going on under the hood? How can one little sentence have so much power over this giant, complex system and make it refuse a user? Well, to figure this out, the researchers had to go deep, right inside the model's mind, so to speak. And they suspected that the answer wasn't in the words of the prompt itself. Nope, it's all about how the AI represents those words and ideas internally. Okay, so this brings us to a really key idea, what's called representation space. Think of it like this. For an AI, your question isn't words, it's just data. It has to turn that data into a location, like coordinates on a map, inside its huge internal brain. And that location, that's the representation. So if you imagine a map of every possible question you could ever ask, that's the representation space. It's this giant, crazy map where, all the questions about cats are huddled together in one corner, and all the questions about astrophysics are way over in another. And the whole point is, the closer two questions are on this map, the more similar the AI thinks they are. So the researchers had a couple of main theories, two competing ideas about what was really going on. The first idea, let's call it the recognition theory, was that safety prompts are kind of like putting on a new pair of glasses. They just help the AI get better at seeing the difference between a harmful query and a harmless one. But the second idea, the refusal theory, was totally different. It said, nope, the AI can already see just fine. The prompt just makes it way more cautious in general and more likely to say no to, well, just about everything. And what they found was, honestly, pretty surprising. It turns out these models already know the difference between a good question and a bad one. They're actually pretty good at it. On that big internal map we talked about, the harmful and harmless questions were already in totally different neighborhoods. So here's the kicker. The safety prompt doesn't make the AI any smarter at recognizing things. It's not a teacher. It's more like a big, blunt instrument. It just shoves every question, even the perfectly harmless ones, in the general direction of just say no. That's why sometimes your AI feels a little too cautious, right? It's because the safety prompt is a sledgehammer, not a scalpel. Okay, so if the old method is a sledgehammer, the researchers thought, can we do better? Can we build a scalpel, a smart compass that actually guides the model instead of just shoving it? And that's where their amazing solution comes into play. It's called Directed Representation Optimization, or DRO for short. So how does this thing actually work? Well, it's a really clever three-step process. First, it finds the refusal direction on that internal map. You can think of it like finding true north on a compass, but for saying no. Then, step 2. When it sees a harmful question, it very carefully and gently nudges that query's location on the map towards that refusal direction. But here's the really brilliant part, step 3. For a totally normal, harmless question, it does the exact opposite. It pushes its location away from the refusal zone, which helps it stay useful.
Okay, so that's the theory. It sounds great, right? A precision tool instead of a sledgehammer. But does it actually work in practice? Well, the researchers put it to the test. And let me tell you, the results are kind of jaw-dropping.
Just look at this chart. It tells the whole story. Using a standard safety prompt, the model still went along with harmful requests over 10% of the time. But with the new DRO-optimized prompt, that number drops off a cliff, all the way down to just 1.4%. That is a huge leap forward for safety. Let's just put that in perspective for a second. That drop you just saw, that's an 86% reduction in the model doing something it shouldn't. That's not a small tweak. That's taking a very leaky bucket and making it almost completely watertight. Okay, But what about when people try to get clever? When they try to trick the AI into breaking its own rules. We call these jailbreaks. Well, even against these tricky attacks, DRO was incredibly tough. The standard prompt, it failed and complied over 13% of the time. But the DRO prompt, it held the line, failing only about 3% of the time. Way, way more robust.
But here's the million-dollar question, right? If you make an AI safer, do you also make it dumber or just more annoying to use? We've all been there. You ask a totally normal question and the AI says, sorry, I can't help with that. It's super frustrating. Well, unbelievably, DRO actually improves this. It reduced the number of times it said no to safe questions, all while keeping its general performance level. So you get the best of both worlds. It's safer and less frustrating to use.
So this whole discovery is way bigger than just safety prompts. It's a whole new paradigm for thinking about how we control AI behavior. We're moving beyond just telling it, don't do this. Now we're starting to understand its internal world and learning how to steer it with real precision. And this is where it gets really, really cool. Think about it. If there's a refusal direction on that internal map, what else is on there? What other concepts could we find and learn to steer towards or even away from?
I mean, just imagine. What if you could find a creativity direction and just dial it up when you're brainstorming? Or a simplicity direction when you need something complicated broken down for you? Or maybe a formality dial to change its tone from casual to professional? This idea of finding these conceptual directions and steering along them, it's the real legacy of this research. It could be the key that unlocks fine-grained, predictable control over how these AIs behave. It's so much more than just a simple on-off switch.
This is for entertainment purposes only.